In case no, unmute and tell me, okay? So in the last class, we were discussing about unambiguous arithmetic expressions, right? We had a grammar, E derives E plus E derives E star E, and E derives open bracket, E closed bracket, and E derives ID. So over two classes, we saw what do we mean by having ambiguity in the grammar and how to remove the ambiguity, correct? So if we have to summarize that, we say a grammar is ambiguous if it fails in specifying associativity. So what do I mean by associativity? If you have an expression like this, ID plus ID plus ID, correct? And if you create two trees for the same expression, maybe in the first expression, the lowermost subtree will have ID plus ID, left ID plus ID. And in the second one, the lowermost subtree might have ID plus ID in the right side. Basically, what we are trying to say here is you have two different parse trees for that particular string. And why we are talking about associativity is because it's a plus in both the places, ID plus ID plus ID. So which means what? The precedence for operator here is same. In reality, what you have to do is, you have to evaluate this expression from left to right, isn't it? Correct? So, but this case, what happens if you have two parse trees, and if you see this, in this parse tree, it will be lowermost subtree, and in this parse tree, you will have the rightmost subtree, which is at the lower level. Okay. So here first this will be evaluated, and in this parse tree, the rightmost expression will be evaluated first. Of course, it's no issue. Just give me a second, okay? In class idea.
Just.
Okay.
Ten 15 allowing video.
Give me a second to connect that board, okay? Okay. So as I was expressing, so for this parse tree, ID plus ID plus ID, we might get two trees in the old expression, okay? So E plus E, and then I might expand it like this. And as we know, each E will be expanded to ID, right? So another parse tree for the same can be E derives E plus E, and I can choose to expand this E first. So I have ID, 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 correct? So we have two parse trees. So this one is there, no? That responds to this parse tree, which means we'll evaluate this first, okay? And this expression is talking about this parse tree where we evaluate the expression which is there here. Of course, you may think what is the big deal, isn't it? What is the big deal? The result doesn't change. But it is not the same if you have into and division, isn't it? Into and division also have same precedence. So associativity has to be from left to right. So associativity is important. Okay. So when do we say a grammar is ambiguous? If associativity is not properly handled. That's what we are talking about in this case A. Okay. And what about the second point? In the second point, we are talking about precedence, correct? So you can see here, it fails to define a precedence hierarchy for the operation plus send star. Again, this example also we took in the last class and we saw, isn't it? We had two subtrees for this. Here, even precedence rules are not followed or they are violated, giving two different results, okay? So this we have done our last two classes, so it should be in your mind properly, okay? The grammar we saw was E derives E plus E, E derives E star E, E derives open bracket, E closed bracket, and E derives ID, correct? So because it is ambiguous, we have to make it as, we have to see if we can remove the ambiguity from this grammar. All right. So of course it is possible to remove ambiguity from this grammar. In the last class also we have seen one example where we removed ambiguity from some grammar. We introduced a second symbol over here, right? That means wherever we had recursion, right, and two recursions, both left as well as right, we chose to remove one. We chose to remove the right side recursion by introducing a different symbol in this place, right? So that's what we have done here. E derives E can be written as E derives E plus E1 or E derives T. Why we chose the name T is because we'll call it as a term, that's why. Okay. So obviously the next will be E derives T, correct? Because this E is called as T, we also have to introduce E derives T. Now let us come to this term. E derives E star E. Okay. We know that this E is also called as T. So I will replace it as T derives T star F. Okay. This one, I'll replace it as T derives T star F. Why am I calling F over here? Because again, I do not want to have the recursion. Okay. Now T derives F, so I have to introduce that. Correct? So next one is F derives open bracket E and F also derives ID. By doing this, I am taking care of both associativity as well as our precedence hierarchy rules. I'll repeat again if you have forgotten, but I think you wrote it in the test yesterday, so you may not have forgotten. In the last class, I explained that to remove ambiguity, we have to remove right recursion, right? So this can be written as E derives E1 and E derives E1, correct? So I said we can replace it like this, where you have replaced this E as E1, isn't it? So E derives E1. That's what we can write it as, correct? The same thing we have done here. Only difference is instead of calling it as E1, we have called it as T. I'm calling it as term. An expression can have an expression plus a term. Okay, the name chosen is term, right? So similarly, now this is E derives E star E. From here onwards, I said E derives term, correct? So it's like I want to write it as term derives term star term. But again, this will have recursion, so I have to remove this. So now it will be term derives term star something else. So we call it as factor. So I need to introduce these two, right? So that's what we have done here, correct? And then from there onwards, you can see term derives factor it has become. So I'll call this as factor derives. Instead of calling it as factor, I can also keep it as an expression because ultimately it's same. Okay. And then finally F derives ID. So by doing this, the ambiguity will be removed from the arithmetic expression grammar, because if you have identical operators, identical means those who have same precedence, then branching will be forced to go in a single direction, that is towards left. And if you have precedences, then we have added different levels here, right? As term and then as a factor. So precedence is there, so we have added the levels so that it also takes care of the precedence hierarchy. So since it's an unambiguous grammar, now whatever we saw in the previous classes, this expression which gave us two parse trees, now will result in only a single parse tree. We have made the grammar like that, we'll get a single parse tree. Let us see now. E derives, because I need plus, isn't it? So I will start it as E derives E plus T, correct? Now next, I need this into. if I need this into, the only way for me is to expand T. I cannot do anything with this E. Correct? So I will have to do it as T star F. Alright. T star F. Now next, all of these three have to be converted into IDs. Right? So if you see the grammar here, to convert this into ID, right? So this E has to be first, this ID you can derive only from factor, correct? So factor is derived from T is derived from E. So E derives T derives factor, and then it becomes ID. Similarly, this T becomes a factor and then it becomes ID, and factor has become ID. This is the only way to derive, okay? Only way to derive a parse tree for this expression. Whereas in our earlier grammar, we derived two parse trees. So that kind of proves that this is unambiguous, correct? Sometimes, I mean, is this clear, or you want me to say anything? Can you put this in the chat box? Have you understood this? Can I move ahead? Is it clear? In chat box, please tell me whether it's clear. Okay. If it's clear, I'll move ahead. If you have doubts, please ask me your doubt. Unmute and ask me. Otherwise, I'll go ahead. Okay. Sometimes what happens is, from the grammar, you cannot remove ambiguity at all. For some questions, when we write grammars, we cannot remove ambiguity. Such grammars are called as inherent ambiguous grammars. Okay. Whatever grammar you write, any format, that will be converted into an ambiguous grammar itself. Now see one example over here. You have a grammar like this: a power I, b power j, and c power k. That is, I number of a's, j number of b's, and k number of c's. But along with that, what else he has told? I, j, k. That is, either I is equal to j, you can see here, or j is equal to k. That means you might have equal number of A's and B's followed by some number of C's, or you might have some number of A's followed by equal number of B's and C's. Correct? So this is like first question, equal number of A's and B's can be written like this: A power n, B power n, C power m. Correct? Similarly, the second part, that is some number of A's followed by equal number of B's, can also be written like this. Alright. So that means the question is telling I need to have a language which gives me a union of either the first one, correct, or the second one. There is no confusion, it's not difficult. Equal number of A's and B's, because I is equal to J, followed by some number of C's, or some number of A's, J is equal to K. So these two should be same. So how do we write grammar for this? For this you have already written the grammar, right? Let us say, because it's a union of two, you can say S derives S1 or S2. Let us call this as S1 and S2. Union is OR, isn't it? So S1 or S2. Now what about S1? So we know how to derive grammar for A power n, B power n, isn't it? Right? So we will say, you can see here, S1 derives S1C or A. Okay? S1 derives S1C or A. What do we mean by an A here? Equal number of A's and equal number of B's. So we can say A is equal number of A's followed by equal number of B's or epsilon. Alright. Similarly for the second one, S2, right? You are deriving equal number of B's followed by equal number of C's or epsilon, and then for the beginning part, some number of A's. Now suppose, I hope this is clear, otherwise I'll repeat once more. Okay. So I hope this part was clear. So your language S is either S1 or S2. Alright. So how will I write S1? S1 is this part, isn't it? So for this part, right? So this language I can say S1 derives S1 or S1C, S1C or A. What is this A? This A is to replace this S1. I'm going to write an equation for this. So that's why S1 derives A, which means this first S1 can be replaced by a A. So what is A? Equal number of A's and equal number of B's. Okay. So that's clear. Same thing for S2, isn't it? So S2 is equal to, here first A comes, here C was different, so here A is different. So A, S2 or B. And this B is used to replace this S2. And that B is for equal number of B's followed by equal number of C's. Okay. So that's how we wrote this grammar. Now let us consider a string called as A square, B square, C square. If I do this, okay, now from S1 also I can derive this, from S2 also I can derive this. Which means what? It is ambiguous. So that means, can I change how I write this S1 or S2? No. That is the only way to write S1 and that's the only way to write S2. So you cannot change the grammar. But still there will be a string like this where you have equal number of A's, B's and C's, for which you can do the derivation from both S1 as well as S2. Right? You can see the example over here. For AABB, CC, A square, B square, C square, whatever is written. From S1 also I can go on deriving, right? From S2 also we can go on deriving. So suppose you have you have a grammar like this which generates a language in which there will be at least one string with two derivations. Then we call it as inherently ambiguous grammar. Means you have nothing that you can do about it. Okay. So now let me move on. I mean, is this clear? Can you tell me in the chat box? Is this clear? If you have understood, I'll move ahead. Is this clear? Only Neha is answering. Others are not answering. So I don't know. Can at least if you haven't understood, can you unmute and tell me what and where you haven't understood? Okay, I hope you will unmute and ask me if you have doubts, okay? Okay, so since some of you have said you have understood, I'll move on to the next topic, which is called as normal form. So far, the grammars we have seen are not in any form. Some rules we talked about is, that is left hand side. So far we have talked about is left hand side should have non-terminal, single, correct? For context-free grammars. That was the only rule we talked about. And right hand side can be combination of terminals and non-terminals. This is what we talked about. We can further impose some rules on the context-free grammars and call it by different names. First of all, why do we need to impose rules? Because when you impose rules, it's easier to understand. Okay, because when you impose rules, everybody will follow that and they will give a same grammar. They will understand the same grammar. They will give the same grammar. Okay, so you can see here. So if you put restrictions, usually they are helpful in database processing. I think you are studying database, isn't it? Where you write queries and where you get the answer. So there is a rule how you write those queries, isn't it? Like select and after this term should come and when should come after this, like that. So if you have rules, it's easier for understanding, also processing. Okay. And also if we have logical formulas, okay, which is used for artificial intelligence systems like that. Again, if rules are imposed, these systems can be written in more simpler way. All right. And parser that we build, like you will have a parser for Java, C, C++, etc., isn't it? So those parsers also, when we build, if we make some assumptions about the rules that the grammar has to follow, then it is easier to write them. Because if you remember, all these will be written by multiple programmers, right? So if there is no rule, if one person is writing half a parser using something which is there in his mind, the other one writes another half a parser, there will not be compatibility between those parsers itself and it's fail. So that's why we always, put some rules and we follow the rules. Okay. So CNF is very easy, right? So normal forms, there are many, okay? And for you, we'll talk about CNF and GNF, okay? Grayback normal form and Chomsky's normal form. What does the Chomsky's normal form say? Very simple. It says, all my grammar should have only these two. That is, a non-terminal should derive a terminal, or a non-terminal should derive two non-terminal symbols. These are the only things allowed. So, if you have written a grammar which doesn't have this, please use rules and convert it into this. Okay, that's what is about CNF. I hope this is clear. By doing this, what you are doing, simple. If we have a tree, we are always forced to branch them into only two factors, because one non-terminal is giving rise to two non-terminals. Or at the leaf level, because it is at the leaf level that you will have the terminal symbols, isn't it? So only at the leaf level, you will branch it into one. So only at the leaf level, branching factor will be 1, and at every other level, branching factor will be 2. So that's what Chomsky's normal form is used for, okay? So to generate a positive with that restriction, the next one is Grayback normal form. In this Grayback normal form, the rule says you can have the grammar with this format. The rule says this format is very simple. A non-terminal which will give rise to a terminal and then a set of non-terminals. Okay. There is no restriction on how many there. Is that clear? So only rule is, you can see here, first you should have a terminal, then you can have non-terminal. Of course, you can just have terminals also. When this beta will become epsilon. How beta will become epsilon is very clear from here. Star is there, no? So you can also have an epsilon. Okay. So these will help in making things simpler. So when we give a grammar to you, how do you convert a given grammar into Chomsky's normal form? I'll repeat again. Chomsky's normal form has two kinds of productions which are allowed. A non-terminal which will give rise to a terminal, something like this. Okay. Also a non-terminal giving rise to two non-terminals. So finally whatever I derive should be of either this format or this format. Okay. So this question, they will give you a grammar. Okay, which will not be in the Chomsky's normal form, and they'll ask you to convert this into Chomsky's normal form. So to do that, you see here the grammar, whatever they give, first you should remove epsilon productions. We have already learned how to remove epsilon productions. Next they say remove unit productions. What are unit productions? One non-terminal deriving another non-terminal. So if you have something like that, remove. Why remove? Because my aim is this, isn't it? I have to get it into this format. Then remove mixed. What do we mean by mixed? Mixed productions are where you have terminals and non-terminals combination. So that's not allowed. Why? Because you can see in Chomsky's normal form, either a single terminal or two non-terminals. So mixed productions are not allowed. So you remove them. And finally, remove the long productions. Why I have to remove long productions? Again, because you can only have two non-terminals on the right hand side. So ultimately goal is to get it in this format. Okay. So let us repeat. Remove epsilon productions, first step. Remove unit production, one non-terminal giving rise to another non-terminal. Remove mixed productions. So if you have a combination of terminals and non-terminals, convert them into only non-terminals on the right hand side. After doing that, if it's too long, then you have to remove long productions, because ultimately our aim is to get it into a non-terminal which gives rise to two non-terminal symbols. Okay. Now let us see two problems. Okay. So convert, the question will be asked like this: convert the given grammar into Chomsky's normal form, CNF format. Okay. So how do we do this? Let us say the given grammar is G is equal to S derives AACA, ACA, AAA and AA. Any one of them is there in CNF? No. Why? CNF will be like this. Remember, a non-terminal giving rise to terminal, or a non-terminal giving rise to two non-terminals. None of them are there like that. Okay. Also, A derives, let us call EC, E or A. Okay. And B derives EC or E. And C derives E or EC. Okay, something like this. None of them, other than I think A derives E, B derives E, C derives E. Nothing else is there in the CNF form. So you have to convert. So first rule for you is to check if there is an epsilon production and remove them. Correct? Just a minute, okay. I'll write a different grammar which has epsilon productions, because otherwise we'll skip a step there. We'll not understand a step. So let us say I have an equation like this. Now we got epsilon production here. Okay. Now we got an epsilon production. So let us take step 1. Step 1 says remove epsilon productions. Remove epsilon productions. Okay. Remove epsilon productions. So as you know, here C derives epsilon, correct? You have C derives epsilon. So if you don't remember removing epsilon productions, all that we do is first find which are all nullable, correct? So we have to find the set nullable. So N is equal to C. Why? Because you have a production called as C derives epsilon, which means C is nullable. At the next stage, B gets added to nullable list. Why B gets added? Because it says B derives C. And we know that C derives epsilon, so which means B also derives epsilon. So B becomes nullable. At the next stage, A also becomes nullable, correct? Why? Because you said A derives B here. So A derives B, B derives C, C derives epsilon. So ultimately, will S become nullable? No, because it has two symbols. So even if you make A and C as nullable, you still will have two symbols. So S will not become nullable. Okay. So now how do I rewrite this grammar? Correct. So now G dash is equal to, let us take the first one. So S derives, I'll keep it as it is. Next, A is nullable, no? so I will make it as null. Next, C is nullable, no? So I will make only C as null, and then I will make both of them as null. Okay, both A and C as null. So first I keep as it is, then I make A as null, which means I remove A. Then here in this I have made C as null. I have removed C. Because A and A, B, C are nullable. In the third step, I have made both A and C as null. Okay. Now let us come to this. A derives B bar A. Any change in that? No. It will remain as it is. So A derives B bar A will remain as it is. What about B derives C? No change. So B derives C as well as E remains as it is. And what about C derives? You have C derives EC or epsilon, right? C derives EC or epsilon. So once EC will be written as it is, and then I will make C as nullable. So I have E, and we'll remove epsilon from that. I hope this is clear. You had C derives EC or epsilon. This is nullable. So first time I'll write it as it is, and second time I'll make C as nullable, and we'll remove epsilon. So this is G dash after removing the epsilon productions. Now what about the next step? Step 2. After removing epsilon productions, we said we have to remove unit productions. What are unit productions? If a non-terminal is deriving another non-terminal, then we call it as a unit production. So if we have any unit productions, we have to remove them. Of course, you can see here S derives B, A derives B derives C. 2 unit productions are there. This is not a unit production, okay? When a non-terminal is deriving a terminal, this is not unit production. This is already there in the Chomsky's normal form. Why? To remind you, Chomsky's normal form is either a non-terminal deriving a terminal or a non-terminal deriving 2 non-terminals, correct? So this is Chomsky's normal form. So if you have something like this is already there in the Chomsky's normal form. It's not unit production. What is unit productions? Only if you have non-terminal deriving another non-terminal, then it is a unit productions. So we have to remove unit productions. Alright. So to remove unit productions, do we make any changes in S? No. Why? Because there are no unit productions in S. So my G double dash, there will be no change in S. So you have it as it is. Okay. There is no change. This will remain as it is. What about the second productions? You have to make changes. What? A derives B. So I have to replace B with the right hand side of this B. Okay. I have to replace B with the right hand side of this. But the problem here is this one's right hand side is also having a unit production. So what I'll do is I'll first solve this. Okay. So B derives C or small e. So B derives small e is no problem. It's a terminal. Now this C is unit production. So I have to replace this with these right hand side. Okay. So B derives EC bar E. Why? See, B derives C, C derives EC bar E. So in place of this C, I am going to replace this. That's all. Okay. And originally it had E, but already written, so I don't need to rewrite it. Okay. Right. So C derives EC, E will remain. B derives C will be changed as B derives EC bar E. Now A derives B. So in place of B, I am going to replace it with the right hand side. So it becomes EC or E, and already A is there. So I will write it as A. Okay. I hope this is clear. Right? I'll again repeat, you have to remove unit productions. So where you have non-terminal deriving non-terminal. So I saw the first one, there is no unit production, wrote it as it is. Second one, A derives B is a unit production. If you have a terminal, it is not unit production. Non-terminal deriving non-terminal is a unit production. So I have to replace this B by its right hand side. But if you see its right hand side also has a unit production. B derives C. So let me first solve this. So B derives C. C I checked on the right hand side. So wherever B derives C was there, I replaced it with the right hand side of C. Of course, B has an additional symbol, B derives E, which is already there, so I didn't rewrite it. Next, A derives B. So in place of B, I wrote whatever is there on the RHS of B. And of course, it has its own A. So I'll write it. Okay. So this is step 2. Remove unit productions. Now let us move on to step 3. Okay. In step 3, remove mixed symbols. Remove mixed symbols means, when do we call it as a mixed symbol? If you have a terminal and non-terminal, then it is mixed. Okay, why do I have to remove? Because for CNF, I can have only a non-terminal deriving two non-terminals or a non-terminal deriving a terminal. This is mixed, right? So that's not allowed. So I have to change it. So do we have mixed symbols here? Yes. We have a combination of terminal and non-terminals. So for G triple dash, I will say S derives TA. Wherever A is there, I'm going to call it as TA. Okay. That is, TA is a non-terminal. This is, don't consider it as T followed by A. Don't consider it as a non-terminal and terminal. I'm using this A as a subscript. Okay. So I will write in place of TA, in place of A, I'll write it as TA. Okay. Then A, C, in place of A, I have written TA. Okay. TA, C, TA. Everywhere A is there, now I'm going to replace it as TA. Okay. After doing this, I will say TA derives A. TA derives A. Because I replaced A to TA. Now you can see this has come to this format. Okay. Of course, here we have long productions, but all of them are non-terminals. All of them are non-terminals. What about the next one here? Again, there also, A derives, in place of E, I'll write it as TE. Okay. But do we need to replace this? No. Why? Because they are already in this format. Okay. So here only TE is nothing but E. Okay. Now let us come to the next one, B. So B is TE, C or E. So everything is in this format. Similarly, C is also TE, C and E. Okay. Now you can see on the right hand side, we either have only non-terminals or single terminal. Okay. So those whoever came into single terminal format are already following this. Now the others which have only non-terminals, now I have to bring them to only two non-terminal format. Okay. Only two non-terminal format. So what I'll do is I'll apply step 4. Okay. What is step 4? Remove mixed productions. Okay. Remove mixed productions. Sorry, remove mixed productions was third step. Remove long productions. Okay. Remove long productions. Okay. So how will I do that? Very simple. Now you see here, I will write it as G4 dashes. Okay. S derives, I should have only two, right? So I will say TA and S1. Okay. This one was there, no? S derives T-A-A-C-T-A. I wrote it as T-A-S-1, which means what is S1? This one, right? Now this is S1, but that also has three symbols, isn't it? That also has three symbols. So I will say S1 derives AS2. Okay. So here A and S2. Now S2 has only two non-terminals. So S2 derives CTA. S2 derives CTA. I'll rewrite it again for you. Okay, I'll rewrite it again for you. The first one, if you consider, it is TAACTA. Four symbols are there. But my rule says you can only have two non-terminals on the right hand side. So I will write it as S derives TA. Okay, and these three symbols are there now. I'll call them together as S1. Okay, so S derives TA S1. Now S1 has three symbols. It's like this, isn't it? S derives ACTA. This is 3. I have to convert it into 2, isn't it? I have to convert it into 2. So this is 2. So I will say S1 derives AS2. Okay, and S2 is CTA. Now all of them are one non-terminal giving rise to two non-terminals. Now let us take the second one. Okay, that is S also derives TACTA, isn't it? So let me write it here itself. S also derives TACTA. Now I have to replace this CTA, but there is already a CTA with the name S2. So I'll simply write it as TAS2. Okay, TAS2. Now if you take the third one, again it has three symbols. So TA, and you have to follow it by ATA. Do I have ATA anywhere? No, I don't have ATA anymore. Correct? So what I'll do, I'll introduce a new name for that. Okay, let us call it as S3. So S3 is ATA. ATA. And this is already in the form, isn't it? TATA is two non-terminals. So it's already in the form. So we dealt with this S. Okay. Now let us come to TA derives A. It's already in the form. So no issues with that. Actually, if you see, everything else is in the form only. So you have two non-terminals or single non-terminals. So we are going to put all of them as it is in the final grammar. Okay. I hope this is clear. We'll solve one or two more examples in the next class. Okay. So if you have any doubts, please ask me. Otherwise, you can go ahead and mark the attendance.